All right, I want to pick up with vector scan, and we're going to discuss that question we finished with in regards to the airplane and the crosswind yesterday in the class. We'll rehash that, talk about it again, and then hopefully maybe any other questions in the homework, we'll talk about that. All right, so the first thing with just after class yesterday, I kind of sat down and thought maybe it'd be good to kind of get you guys a visualization of what is really happening when we change things into this horizontal and vertical component stuff with the unit vectors of I and J. Okay, so this does that. It does all the work for you. It gives you the answer. So if I've got, and now, provided that it gives you the answer, I want to go through the work and make sure that we can do the work that gives that answer or provides that answer. But you see what is happening here. I can type in just a vector magnitude here in its direction. Okay, so that gives me the red vector. I can take another magnitude of 4 in a direction of 60. That gives me the purple vector. And then automatically it puts in the resultant for me. And the resultant would be the blue. Okay. So the resultant is if I were to put the red one and the purple one tip to tail, right? Okay. If you see over there up top, I guess, in the black, it works through the fact that the U vector in terms of I and J can be found by taking the magnitude of V times the cosine of theta that is attached to V. So in that case, that's the 30 degrees. I just put subscripts on thetas to know which one's going with which formula. And then plus the magnitude of V sine of theta times J. And then in the line underneath it, it actually takes these values that we came up with over here, or that we typed in over here, and inserts them correctly. And then it just evaluates that. So 2 cosine of 30 gives us radical 3. 2 sine of 30 gives us 1. Does that make sense? And it puts it into that I and J format for us. It then does the exact same thing with U. Okay, so you've seen it do that here with U. Converts it over to I and J, okay, which should be something we can do pretty easily. And then once we have those things, once we have V and U in vertical and horizontal components in regards to the vector units or unit vectors, we see what happens. So I want to find U plus V based off of what we know for addition of vectors. We can add that 1.73 to that 2. So that's happening right here. And we can add the 1 to the 3.46. So that's happening there. All right. Add those together. It ultimately gives me that vector right there. That's the way that we can describe that blue resultant in terms of a unit vector. Does that make sense? And that's a lot easier than our maybe our alternative approach that we'll talk about here in a moment. But now that I have that, I can simply say that is. If I go 3.73, 4.46, what that means to us is it's referring to the 3.73 being this horizontal component right here that is from 0, 0 to right there. Okay. That distance is 3.73. That's the unit vectors in the horizontal direction that I need to get to the same place that resultant gets me to. Does that make sense? Okay. Then this vector here is the 4.46. Okay. So the 4.46 unit vectors in the vertical direction. If I couple those two together, what is that horizontal vector? What's the relationship between it and this vertical vector? They are what to one another? Perpendicular. So do I have a right triangle here? And if I want to find the hypotenuse of the right triangle, how do I do that? I know that this distance here is 3.73, and this one here is 4.46. How can I find the length of that resultant? Pythagorean theorem. And it tells me that through the Pythagorean theorem, it should give me 5.82. Okay. If that is if that is my right triangle, and I want to know the direction of that resultant, that would be that angle there. Okay. Can I use opposite divided by adjacent? And that's what this here is. The direction of the resultant is giving me just tangent inverse of 4.46 over 3.73. Okay. That is much simpler, much easier in regards to kind of our alternative approaches here. But what I want to show you as we look at these things, I've got the component vectors of v and u being able to be put in there. So there's the component vectors of v. Okay. Here are the component vectors of u. Okay. So, and I know it's kind of hard to see. I just didn't have any better color choices. If I take that vertical component right there for v, and I take that vertical component there for u, if I put those things on top of one another, tip to tail, okay, what length do you think they're going to be? Would they be that length right there? Okay. So when I want to add two vectors together, it's so much easier to add those two things together to get this orange one. And then when I want to do the horizontals, you can't really see it real well, but it's this black vector here, plus then that turquoise vector that's a little bit longer. If I add those together, I should get that orange vector across the bottom. Okay. So that is kind of the logic behind all the steps that we're doing. Okay. But just showing you kind of, you know, the quick way of doing this, we're going to take that information, okay? Vector v then is, all you do is 2 cosine 30i plus 2 sine 30j, and then u is going to be 4 cosine 60i plus 4 sine 60j. Again, you evaluate those two things. So v turns into radical 3i plus 1j, and then u turns into 2 radical 3 I. Okay. I'm sorry, no, it's 2. Sorry. Cosine 60 is radical. Oh, no, so cosine 60 is 1/2, so I'm sorry, that's 2. And now this one here is 4 times radical 3 over 2, so that becomes 2 radical 3j's. Okay, so we should be able to then add those two things together and add those two things together to get u plus v. And then those two numbers, 3.73 and 4.46, they are your A and B for the Pythagorean theorem to find the resultant, and they're your opposite over adjacent to find your theta. Is that going to make sense? And hopefully the process there is a lot more efficient than what I'm about to show you. Okay. And what I'm going to show you is something that we've done before. You know how to do this. We've done this actually probably 3 years. Did it in geometry. We did it in Algebra 2. We've done it in this class. And maybe you've even kind of discussed it in physics. Okay, so let me just clean some stuff up here to give myself a little bit of room. All right, if I wanted to find the length and direction of this vector with disregard to the I and J stuff, with disregard to the unit vectors, you would have to do it this way. You know that this red vector has a magnitude of 2, and it has an angle of 30 degrees. Okay? You know that the purple vector has a magnitude of 4, and it has a direction of 60 degrees. So that would be 60, and that would be 30. And that's 2. Okay. Would you guys agree that I should be able to take that red vector and place it right there instead? Okay. So finding my resultant now would be a segment in this triangle up here, right? Does that make sense? You see that? Okay, so let's try to figure out some information about that triangle. If I know that obviously that distance was 2, so now I can say at that distance is 2. So now I got 2 side lengths in my triangle. I'm looking for now an angle of my triangle. Okay, and this is a little bit more difficult to do, but if I were to take this vector here and replace it up here as that vector, to be the same vectors, they need to have the same length in the same direction. Meaning, if I were to put in a set of axes right there, what would this angle right there be? Be 30 degrees. Okay? What would that angle right there be? 90 degrees, right? And now we still need what that angle is. Does that make sense? Well, if I look at that angle, let's come down here. If I look at these, that origin or that set of axes, okay, is this red angle relatable to that one right there? Because if I just looked at those, just going to do it this way. So here would be that would be the purple vector, okay? If I looked at just the north and south lines there, is that angle right there alternate anterior with that one? Does that make sense? So I can translate. So how big would this angle here be? If I know this black one here is 60, 30. So this one's 30 here. Okay. So how big is this angle right here? 150, isn't it? Okay. So I can replace all that garbage with 150 degrees. Okay. Do I now have, and I'm just going to draw it over here just to clean things up a little bit, but do I now just have that triangle with 150 degrees here, with 4 there, with 2 there, and I'm looking for that distance there? I'm just going to call that distance capital R for resultant. Okay. Can I say that 4 squared plus 2 squared minus 2 times 2 times 4 times cosine of 150, and if I take the square root of that, does that equal R? Does anybody know what I just did there, what I'm using there? It's something we talked about at the beginning of chapter 5. We talked about it in geometry. We talked about it in algebra 2. What can you use? What trigonometry can you use only in right triangles? You can only use SOHCAHTOA, right? Okay. You can only use those things in right triangles. But then we know there are a lot of triangles that are not right triangles, and we still want to be able to find distances using sine, cosine, and tangent. So we develop the laws of sine and cosine, right? Which law is that? Which ratio does it use? Cosine, so it's probably the law of cosines. Okay, so we use the law of cosines here. When I evaluate that, 4 squared plus 2 squared minus 2 times 4 cosine of 150. And then I take the square root of that number. It gives me R to be 5.8186, which which is the exact same thing that the I and J components gave you. Does that make sense? But would you agree that the I and J thing's a little bit easier? That's just kind of a form-fitting set of formulas that we can always set up and convert an I and J and then just use addition. That is so much easier. Okay? But this works. This is fine. Now if I want to find the direction's a little bit messier. Okay? I now know that this R right here is 5.818. Okay, I just go 819. Okay? If I want to find the direction of my resultant, okay, which down here would be just that angle right there, correct? That's the direction I'm looking for, okay? I already know that that angle is 60 degrees, don't I? Okay. What could I do if I was able to find this angle right here in my triangle, which is actually, it'd be this angle over here. If I were able to find that, what would I do with that in regards to 60 to come up with the direction of my vector? I would subtract them, okay? And right now, we have the ability to do that, okay? I'm just going to call this theta here, okay? Actually, let's call it, I mean, it doesn't matter, but since usually theta is what we talk about as that angle, let's call this alpha, okay? If I was just trying to find alpha, I can take that angle, because it's unknown, and the side opposite it, which would be 2, and set that equal to, now an angle that is known, sine of 150, and the side opposite it that is known, 5.819. What am I using right there? Law of sines, okay? Now, I'm going to erase this and do my work over here for the law of sines. It becomes, 2 sine of 150 should equal 5.819 sine of alpha. So I'm just going to divide both sides by 5.819. That would equal sine of alpha, but I just want alpha, right? So through our algebra, and I'll let you kind of rehash that on your own, but once I take the sine inverse of that information there, it should give me alpha. Okay? So now I'm going to evaluate that, and when I do that, I get 2, so let's go, 2 sine, sine inverse of 2 times sine of 150. We're going to divide that by 5.819. Okay. And now it gives me alpha to be 9.895. Okay. 9.895. That is that angle right there. What did you say you needed to do with that to actually find theta? Subtract it from 60. So 60 minus 9.895, 50.104 degrees, which is that right there. Okay. My hopes are, though, that you recognize that if I were to come up with this information right here, okay, if you take your calculator and type in tangent inverse of 4.46 divided by 3.73, it gives you that 50.1. If you were to type in the square root of 3.73 squared plus 4.46 squared, it gives you that 5.82. Does that make sense? And that circumvents all the work that we would have to do with the law of sines and law of cosine. Okay? A lot of time consuming processes there if we neglect the vector or the unit vector approach. Is everybody on the same page there? All right. So you start to see, I think it's a great aspect of mathematics is that, yeah, we have two approaches, but now you kind of start to see the benefit of the second approach. Okay. It's an efficiency thing. It's a, a calculation idea where, essentially all I'm doing is adding things together when I use the unit vector approach and maybe taking square roots of a few things, but it's much simpler than the law of cosines. Okay. So yesterday we visited that question where the airplane was traveling at 300 miles per hour, and it was going due north. Okay, so it's a very large vector here. We also had then a 40-mile-an-hour wind, but it was traveling at north 30 degrees east. So north 30 degrees east is 60 degrees from standard position. So these thetas I got to plug in are from the positive x-axis in standard position. So this is what the picture should look like. Let me zoom out here. The axes to... All right, so there's the airplane's vector. Okay, there's the wind's vector. Now understand the airplane's vector, even though I've got the axes kind of not to scale here. So this is actually, this red one is actually longer than the purple one. Does that make sense, everybody? Okay. But if I look at the resultant being this blue one, okay, we could take this thing, put it down into its horizontal and vertical components, which were, let me see, I've hidden them. Actually, I don't think I hid them. I think they are off the page somewhere. Well, we can look at this. So this one here was the, it would have been 0, I, and 300J. Okay. This purple one would have been 20I plus 34.64J. Okay. When I add the i's of those two vectors u and v together, and I add the j's of those two unit vectors together, I get this thing right here. Okay. So then when I want to know the length of u plus v, it is simply 20 squared plus 334.64 squared, and then I take the square root of that sum. Okay. And that will give me that number right there. Okay. If I want to find theta, I simply take tangent inverse. Okay. Now your j is always your y value, so it's going to be 334.64 all over 20, and that will spit back that number right there. Okay. That is so much quicker and easier than the law of sines and law of cosines intertwined. Okay. Does that make sense to everyone? Okay. Let's quickly, and I say quickly, that might not be the best way of phrasing this, but let's, because I don't know if it's going to be quick, let's do this problem with the law of sines and law of cosines, because I think it's a good practice for your final next week, because there are a handful of questions that ask you to use these two laws. So if I've got, and it's a little bit easier with this question than that first one I introduced to you, for the mere fact that one of our vectors here is the positive y-axis. So this here is our airplane. Okay, so that's 300 miles per hour. Okay, we have a crosswind, which will turn into maybe that vector there. Said it was 40 miles per hour. We want to come up with what our resultant would look like. So our resultant bear with me here. I guess I can't use that. My resultant would be that dotted blue line. Okay, so that would be u. If this is u and this is v, this would be u plus v. All right, so we got to find some information here. They told us again that this angle measurement here was 30 degrees, correct? Okay? We went, if that's north and this is east, they told us that the wind was blowing north 30 degrees east. So they're providing me that angle, which is nice. Okay? Meaning that if I were to put in some axes right here, how big is that angle? It would be 60, correct? And this is the nice aspect of having one of our vectors being an axis. That angle right there is 90, correct? So when I look at my triangle, just going to pull this off to the side here. When I look at my triangle, where that is my resultant, what is this angle right here? It's that angle there. So it's 150, correct? This is 300. This is 40. So now law of cosines. Remember, law of cosines is, if I call this r, I'll just write that r is equal to the square root of what turns out to be a squared plus b squared minus 2ab cosine of angle r. Okay? Put an angle there. So, and a and b are the remaining sides. Okay, that you should know. That's what we're plugging into this formula. So it'd be A would be 300, B would be 400, or sorry, 40, minus then 2. That 2 is a constant. It's always 2. And then we go 300, 40, and then the angle that's opposite the side that I'm looking for in this case would be 150. Okay. So I'm going to calculate that real quick. Okay, so take square root of 300 squared plus 40 squared minus 2 times 300 times 40 times cosine of 150. And do we get 335.24? And that's what we found using I and J. Okay. So the resultant is equal to 335.24. Okay. Now I need to find my direction here, so I'm looking ultimately for this angle here. Okay. So if I call that alpha, can I say that the sine of alpha over 40, so that angle that I'm looking for, divided by the side that's opposite it, is equal to, now I need the sine of an angle and a side opposite it, and those two things both need to be known. So the 150 is the known angle. So now I know R to be 335.24. So you're going to be 40 sine of 150 is equal to 335 times sine of alpha. So I'll just divide both sides here by 335.24. That gives me sine of alpha. So what do I need to do with both sides to find alpha? Yeah, sine inverse. So sine inverse of that should give me my alpha. Okay, so calculate that real quick here. So sine inverse of 40 sine of 150. Divide then by 335.24. Gives me that number there, 3.42. 3.42 is that angle right there, 3.42. So it's the same as this angle right here, which that is actually kind of directly related to how I want to write my answer. My answer I want to write, because I think the way the question asked it is that it said write it as a bearing. We call these bearings. So would you guys agree that I would be heading to represent this dotted blue vector? I would be first heading in a northerly direction, but then how far are you going to deviate to get on this course of this dotted line? 3.42 degrees. In which direction are you going to deviate towards? to east. Okay? That is analogous. That is saying the exact same thing as describing theta in this case. Okay, how can I find what this angle theta is? Yeah. And that ends up being, so 90 minus 3.42, 86.6. Okay, which that was exactly the same. Okay, if we start to draw some comparisons here, we do all that work. We do all that work, and bear with me real quick. Well, I can't show both at the same time, I guess. Yeah. So if I would have taken 334.64 divided by 20 and then to take tangent inverse, it gets me that 86.6 a lot quicker than the process that we had to do to find the 86.6 here, right? To find that here, I had to use law of cosines, law of sines. Obviously, from me asking the question, what is that formula, and I heard nothing, we probably don't want to use law of cosines, law of sines very often, do we? It sounds like we maybe not, or we might not have that memorized or know that we should be using it, okay, or that we can use it. I'm just trying to hit home right now with you. Your final is in about, what is today? Wednesday? It's going to be here in 6 to 7 days, and you need to be able to do law of sines, law of cosines, okay? If you're preparing for that, hopefully you are, go back and start looking at those things, and also pay attention to the ambiguous case and the law of sines, because it's asked on that test, okay? Just kind of hopefully open your eyes to the fact that, we've already taken one final in a college algebra class. Trigonometry final, I think, is more difficult. It's harder, okay? There's more information, there's more geometry involved. So please be doing the necessary things to address that. What a question about number 2 in the homework. So just go over that. And this is actually a question that is similar to something that you're going to see on the final as well. Okay, this is one of the couple of vector questions that are on the final. Now, not exactly, but pretty close. Okay, here it says a river flows due south at 1.4 miles per hour. It says, in what direction should the swimmer head at a velocity of 4 miles per hour in order to arrive at a landing point? I think it says directly across. Yeah, due east, okay, of his starting point. So due east means exactly to the east. Does that make sense? There's no deviation away from that, okay? So whenever they say due south, due north, due east, due west, those are 90-degree increments. Is that all right? Okay. So I kind of draw the picture here. If the current is taking you that way, so that's 1.4 miles per hour, okay? Now think about what we're actually trying to come up with here. When I swim straight, when I want to get to right here, okay, that path right there is actually the resultant, okay? So I'm going to do it in green here, because that's where I want to get to, right? That's the, if I'm starting right there, then this spot right here would be due east of it, right? Across the river. Do you guys, can you visualize that the question at hand is how far, and when I say how far, I'm talking about a direction, a degree. Do I need to swim into the current? Okay. If the current is flowing that direction, don't I need to swim that way so that it pushes me down to get over here? Does that make sense? So I'm looking essentially at that vector there. Okay. Would that vector right there be the same as that vector? Which, and that blue one is going to be maybe the same as that one, right? Do we see here that this vector here, which is what I need to swim, okay, this is, I don't know how to label it, just call it just U, okay? And I'm traveling, I'm swimming at a velocity of 4 miles per hour, okay? That vector there plus this vector here, okay, provides me this green vector, doesn't it? So you see how when I said that the green vector is actually a resultant? It's because it's the resultant of what you have to swim and the current acting on you. Okay? So I need to figure out what angle I need to swim at. Would you guys agree that it's that angle right there? If I know, if I'm starting here at the bank and I want to go straight across, then I need to figure out how, from straight across, from standard position, how many degrees do I need to swim into the current? So if I have that information, how do I find that angle theta right there? If this is a right triangle, how would you do that in like the third quarter of geometry? Yeah, sine inverse. So sine inverse of 1.4 divided by 4. If we do that, arc sine 1.4 divided by 4. Okay, it gives me that number right there. Okay, so I write that number down. Now think about this. 20.48 degrees. Okay, so if they just asked for a pure theta, I think that's probably what I would answer with. But you see in the problem that it actually asks you for a bearing, right? It said a north, left a blank, and then put east, correct? So if I'm, the idea then is if you're trying to travel this vector, that's first in a northerly direction, right? Okay. But then how far do I have to deviate to the east? I would take 90 and do what with that number? Subtract this. So 90 minus that number. Gives me my 69.5 that we're looking for here. And that part, the 69.5, I mean, if you can get the 20.48, great. That's what I'm really concerned with. The north, 69.5 degrees east, I think that's something we can do. We have the capacity to do, but you do have to have a little bit of understanding of that kind of school of thought in regards to how we do directions. Okay, or that little content area of directions, which maybe it's something that I think a lot of courses kind of glaze over and assume that people know how to do that. That it's common knowledge, and I don't think it is. So, does that help? Are there any other, we got some time here. Are there any others on there that you guys want to talk about? 8 questions on that assignment. Due here pretty soon. Any other struggles on there? Everybody got all these right? There's no issues. The one thing that I'm seeing, and I sent it out in an email, is that if I, like on number 1, if I had 4i minus 5j and I type that in, it's going to give it to me wrong. If I don't use the I and j that's kind of in their symbol packet, okay, and that syntax drop-down window you got to open up, you go to the vectors tab and use the I and j in there. And it's kind of silly that that's a requirement here, but it is what it is. Is that okay? how does that 4I minus 5J help me determine how fast I'm actually swimming? Because that's what I would really be swimming, right? Okay, because the current is pushing me down. Okay, the current is going that direction, it's pushing me down. Does it? So if I'm swimming across the river 4 miles per hour, the current's at 5 miles per hour. What would be the maximum speed you think you could swim that you be moving? Could I theoretically be swimming ever at 12 miles per hour? If I know that my maximum capacity is 4 miles per hour, the current is 5 miles per hour, what is the maximum that I could be swimming? That's 5 miles per hour. Now I know I got me swimming this way, but what if I were to swim that way? What's the maximum that I can, like 9 miles an hour, right? That's all I could ever swim. So when I do my work here, I should know that because this current is actually an assist current, right? I'm swimming with the current a little bit. I should be bigger than 4, smaller than none as an answer. Okay. So how do I find that? Well, if this is an ij form for this vector, okay. There's the 4, there's the negative 5. How do I find the length of that vector? Okay. So it's 16 plus 25, root 41, a little bit bigger than 6, a little bit smaller, and it says about 6.5-ish. Okay. Somewhere in that ballpark, I would think. Guess what? It's 5 more units than 36, but it's 8 more units than, or 8 less units than 9, so it's probably like 6.4-ish, maybe closer to. But same, it's, it's fine. So now, if I needed to know, okay, that's the speed that I'm traveling at. There might be a question about what that angle right there is. Okay, can I say that angle is tangent inverse of that divided by that? Okay. Now, because you're using negative values, just pay attention to how your calculator spits back that theta, and then how does that theta relate to the angle that we're looking for in our picture, and how does that then relate to maybe the way the question is designed in regards to, does it want a north something degrees east or south something degrees east or something like that. Okay. So putting in that 4I minus 5J is much easier. Now, there is, hopefully you're looking at that, and some of you I know just saw the 4 miles per hour, 5 miles per hour, and they instantly put 4I 5J. Okay, and that's fine, because it works here. And it works here because these are perpendicular, right? Okay. But really what we're doing, what we should be doing, is saying that vector B, okay, let's say is my speed as a swimmer would be 4 cosine, okay? Now, that angle that I'm swimming would be 0 degrees, right? Okay, so 4 cosine 0 I plus 4 sine 0 J. Okay. So when I do that, what's cosine of 0? 1. So I get 4 times I. This goes away, right? So there's V. Now U, let's say that is the vector here of the current. So I would say 5 cosine. Okay. Now that angle would be 270 degrees, right? So 5 cosine 270 I plus 5 sine 270 J. Cosine of 270, 0. Sine of 270, negative 1, so negative 5J. Okay? So then U plus B should equal this plus that, right? And that's where we get 4I minus 5J. That's the most kind of direct logical approach instead of just saying, well, it's 4I and 5J, because those are the numbers that are a problem. Because if they're not perpendicular to one another, if they're not 90 degrees, essentially 0 degrees and 270 degrees, okay, or multiples of 90, you can't do that. You have to go through those formulas. I want you to kind of force yourself sometimes to go through those formulas so that you get used to that. Because on your test, my assumption is I haven't really looked at the details of the problem, but I'm going to assume that they're not just going to be those two numbers plucked out with I's and J's on them. Okay. Be cautious of that. Tomorrow, my hopes are is to kind of wrap up any questions that we have about vectors. There is more stuff about vectors. Your final doesn't address it, so I'm not going to get into it with like dot products and cross products and stuff like that with you at this time. My hopes right now is to prepare you for Friday's test. We're going to have a test on Friday. I know classes are shortened a little bit because it's signing day. The test will be altered so that you can get it done in 35 minutes, 40 minutes. And then next Wednesday, we will start our final for the course, which will be comprehensive.